Hello everyone, my name is Justin Chan, a computer science major in Thomson Reuters University. Throughout the summer in 2021, under the supervision of Kevin O'Neill, a senior instructor in computer science in Thomson Reuters University, I have been developing a software that could automate data collection and analysis for retail business. Today I'm presenting to you this software. It is called DAYTAR. So for testing our software, we have deployed our system in a local restaurant called Beijing Restaurant. It is a Chinese restaurant that offers dining, buffet, event, and takeout. So for our client problem, due to the pandemic, our client don't know when is the peak hour of the business, and don't know when and where to allocate the resources. So resources such as people that help in the dining area, and also when to prepare more food for the customers. So because of that, they have a lot of food waste during the pandemic, and which at the end of the day will affect their total revenue. So for our solution to fix this problem, we have developed a software that can automate data collection for the customer demographic data, such as the gender, the age, the ethnic group, and the count, so that we can use this data to analysis and also predict the future trends for the businesses. This software is not only for the pandemic use, it is also for later future use for the business. So the use can be used as knowing the demographic and push out event and deal according to based on the data that we have collected and analysis, and also you can know about the peak hour of the business, so you can prepare accordingly. So for the requirement of our software, so our software will be able to collect the visitor demographics data such as age, gender, ethnic group, and account. Able to run throughout the whole business hour. So I'm gonna be 7 days per week, and also able to track the visitor and assign an ID to them, so they will not have any duplicate data and etc. So and also we were able to detect the visitor demographics when the person is walking in high speed. So we're not going to have any inaccuracy data that collect in our application. So for our function, we have made an user dashboard for the user to have an easy understanding of the data that it representing, so that the business owner can have an easy understanding of what the data representing, and able to run on a microcomputer, which we will talk about later, and also able to see the camera feed through our wireless device. So for training our KRAS data, we use KRAS and UTK bases, which is a database that have collected more than 400,000 faces around the world with the demographic data such as age, gender, and ethnic group. So we use this data to train our KRAS deep learning algorithm using the neural network. So as you can see on the screen, is our testing of our model by myself, and here's our neural network that we built using KRAS to train our model. And how does this application work? So it works by when a customer walk into the area that our camera have set it. When the customer face have been detected and touched the detection line that we have set it. We have set it a horizontal and vertical detection line. So for different area of deployment. So when the customer faces touch the detection line, the camera will then send the camera feed into our detection algorithm and save into a local memory. So after a certain time, that data will be sent into a CSV file, which later on will be sent to three different CSV file, which is the temp data, which is local memory, uh, data close, which is the day close, sorry, day close, which is the current day, and the overall data, which is the lifetime of the application deployment. So where did we deploy the system? We have tried three different locations, and at the end we have settled in the top of the staircase. The reason why we tried different location to deploy our device is because of the lighting issue. So for the whole day, the lighting will be changed on the business location, and the camera is sometimes have a hard time to understand and detect the human faces. So at the end of the day, we have settled on the top of the stairs because it have even lighting for the whole day and have the best accuracy out of this three location. So for hardware, we use just Nano, which I've showcased in here, which is microcomputers with NVIDIA chipset that have been developed by NVIDIA, so that we can use we can have good support with the help of the graphic power from the graphic chips that NVIDIA have been created. So here's our enclosure that for our hardware, and we have been deployed that on top of the staircase on the business, which you can see on the screen. And the reason why we do that is because we want to create a pleasant experience for our customers, and our customers don't have to be starting the application every single day. And in this approach, the customer can we just need to set up this define to our customer location, and the customer can just operate their business like before, and without any hassling of opening software and dealing with errors in software. So this software will be run 24/7 when you plug into the power outlet, and we'll start to collect data and analyze the data. So here's our application showcase. As you can see on the screen, on the top left corner is going to be our live feed of our camera feed. On the top right, you're going to be our lifetime visitor trend prediction and analysis. The bottom left is going to show how many customers have been visiting your business in the current day. And on the bottom, you can see the current day trend. So you can see all the data, including age, gender, and ethnic group, have been graphically displayed for the whole application, so that the business owner can have a better understanding of the data that you're representing. Here's our streaming application showcase. So as you can see, I have opened my software on my desktop and can be streaming on an iPad and other devices such as a laptop and iPad. So here's our visitor trend data showcase. So this is gonna show up from Monday to Sunday every single week, and our visitor trend using the data that you collect over the lifespan of the application. So as you can see, the current hour and the day have been highlighted using a red bar chart, a red bar, so the visitor can have an easy understanding of the data that you're presenting. So for our data output showcase, here's just a showcase of how the data gonna look like in Microsoft Excel files. And so here's our limitation of what hardware we use. So our software can operate on Windows, Linux, and Mac OS. So for us to run on Linux, which is just Nano in this case, The software can only collect data collection and can have a resolution of 240p. Um, but the downside of it is it doesn't have voice streaming, user dashboard, and the launch application because of the computing power of just Nano have. But if you use Windows and Mac OS, you can have resolution up to 1080p and also have voice streaming, user dashboard, and able to run and able to auto start the program from the start. So here's our checklist. We have tried a lot of approach, and at the beginning we are trying to use IP camera to set up in our client site to collect data. But the problem that we found out with IP camera is the latency and delay of the camera feed, which is hard for our OpenCV program to process the data. So at the end of the day, we have scrapped this idea. So as you can see on the screen, this is so far what our application can do, and here's our documentation of the software. So the reason I did this documentation so that later on, if anyone wants to be accessing and work with this project, they can just look at our documentation and have a very good idea and understanding of how the program works and how every single part of the code are representing. And here's our user manual, which is for our business. This manual have been talked about how to set up the hardware. The hardware include just Nano, Windows, and Mac OS, and also how to troubleshoot our systems. So here's our application showcase. And thank you for everyone and your time of listening my presentation. And thank you very much.